so today we are going to start looking at the unit circle. And so the first thing I want you to do is I want you to take your paper and fold it in half because it's going to be easier to do before we start than after you finish. And we're going to start with it folded, looking at these triangles. So your triangles all have right angles in them. I printed out a white copy of this because my document camera doesn't like the colored paper, and I printed off the wrong one that I left these off of. So let me get these back in here real quick. And then we are going to review once again our special right triangles. So up at the top here we have 30, 60, 90 triangles. And as we reviewed the other day, across from 30 would be S, the hypotenuse would be 2S, and the long leg would be S times the square root of 3. So the other day when we did this, we made S 1 so we could make the hypotenuse 2 and the long leg square root of 3, but really we could make a side length anything we wanted to and then figure out the other two. So today we want the hypotenuse to be 1. If the hypotenuse is 1 and that's 2S, that means S has to be 1/2. And then that would make the long leg, once you multiply it by the square root of 3, square root of 3 over 2. Okay, that makes sense? All comes from special right triangles. All right, so now grab your two green triangles and set them next to each other like this. So they look like this picture right here. On your green triangles, put in the right angles. And then in this first little triangle, we're going to put a Roman numeral 1. In the second one, we're going to put a Roman numeral 2. And do the same thing on the green triangles themselves. Roman numeral 1, Roman numeral 2. You'll notice that they're labeled just like the one we labeled on the paper. We all good? Okay, so now we're going to take our little green triangles and move them out of the way. And you're going to grab your yellow triangles and set them like this so they match what's on the paper. Once again, put your right angles on the yellow ones. In the first one, we're going to put a Roman numeral 1. In the second one, we're going to put a Roman numeral 2. And then do the same thing on the yellow triangles. Okay. We all good with our yellow ones? Okay, so then we can move those out of the way, and let's talk about the 45, 45, 90. So remember that 45, 45, 90 would be leg, leg, leg square root of 2. And we want the hypotenuse to be 1. So if the hypotenuse is 1, that means that L square root of 2 equals 1. So L equals 1 over the square root of 2. And when I rationalize that, what does that become? Square root of 2 over 2. Very good. Okay. And if you grab your pink triangles, you will notice that that is how they are labeled. Set them down so that they match up like what's on the paper. We're going to add our right angles in there. Roman numeral 1 in the first one, 2 in the second one. Same thing on the triangles. Okay. Everybody with me? Got our triangles all nice and labeled? All right, so then just move all the triangles out the way for a minute. Let's open this up and look at the circle. Okay, so what makes a unit circle a unit circle? A unit circle has a radius of 1. Okay, if this radius was anything else, then it's just a circle and it's not a unit circle. But this radius is 1 unit of whatever unit it is. It's just 1. Okay. On here, you have this point where it would start at 0. As this point rotates around on the circle, it hits different angle measures. I have them on here in degrees and in radians for you, so we didn't have to fill them out and somebody write something down wrong. The radians become way more important to us. We really don't care about degrees much anymore. We'll talk about them a little bit just because it'll help you kind of tie everything together. But I'm never going to, I'm not going to ask you what is 210 degrees in radians, and you just have to know it. If I say what is 60 degrees in radians, that you do have to know. But the rest you can figure out, and it doesn't really matter because we're not going to worry about these in degrees anyway. I'm just kind of showing you what they are. What you need to know when you walk through the door tomorrow, for sure, without hesitation, is what the radian measures are for the first quadrant angles. 0 should be really easy because it's 0. 90 is pi halves. We should be able to get that from everything we did yesterday, no problem. And then you've got 30, which is pi 6, 45 is pi 4, 60 is pi thirds. The 30 goes with the 6, the 60 goes with the 3. Just remember that they're opposite. These will not be difficult for you to remember. There's a lot of stuff you have to know about the unit circle, and you have to know, not be able to figure out and not memorize. Memorizing is one thing. Learning it and knowing it is something completely different. I don't expect you to know it all at once. I don't expect you to come back tomorrow an expert at the unit circle. I'm going to baby step you through it, give you ways to know this stuff and remember it, but you have to stay with me and you have to practice on what I'm telling you to practice when I tell you to practice it. If you just put it off and think it'll just be no big deal later, you're wrong, and you will struggle for the rest of the year in here and all year in calculus. Okay, so it's super, that's how important this is. So the only thing, we're going to do a lot today, but the only thing I expect you to know for sure, 100% without hesitation and not trying to figure out, is just what these radian measures are. Okay, make sense? And again, they'll come up so much, it'll be easy to remember. All right, so let's look at this. We're going to fill in all these ordered pairs because that's something else that you're going to have to know as well. But knowing that this is a unit circle, we can go ahead and fill in easily 4 of these real quick. What would the ordered pair for this point be if this is a unit circle? What would it have to be? 1, 0. The radius is 1, that's 1, 0. So then what would this one be up here? 0, 1. And what would this one be over here? Negative 1, 0. And this one would be 0, negative 1. See how easy that is? Okay, so the rest of this is going to come from our special right triangles. So when you did special right triangles in geometry, if you thought, oh, I'm never going to ever use this again, boy, were you wrong. Okay, so I want you to grab your green Roman numeral 1 triangle. It has a Roman numeral 1 in it because it's going in the first quadrant. So I want you to put it down in the first quadrant. It should line up all nice and perfectly at the vertex, and then at that point and on the x-axis. Once you have it lined up like that, you want to take a little piece of tape, maybe about 1 inch, and you're going to tape it down just on the x-axis, kind of right over where it says 360. Put a piece of tape right there. Just right there, yeah, kind of in the middle. It doesn't have to be perfectly in the middle, but my tape, I know my tape is hard to see. It's right there, kind of where my finger is. Then you're going to get another piece of tape about that same size. You're going to reflect your triangle down. Now, when you reflect it down, it could get all crooked and wompy-jawed like this, right? So you just, once you reflect it down, you line it up again down here in the fourth quadrant, make sure it looks all nice and pretty, and you put a little piece of tape right there. And that way, when you reflect it back and forth, it doesn't get all crooked. Okay, so it doesn't have to go all the way across. It can just be right in the middle and it'll work just fine. Okay. Then we'll put it back up in the first quadrant and talk about some things here. All right, so this angle right here that's at the origin is 30 degrees, which is pi 6 radians. And remember, we really are interested in the radians, so let's write pi 6 in there. So when this point rotated from here to here, it went through pi 6 radians, and now I have an ordered pair here. Knowing what you know about how to plot points and all this information that's right here, the answer to what I'm about to ask you is staring you in the face. What would the x value of this ordered pair have to be? Now that's an angle measure. Square root of 3 over 2. And what would the y value be? 1/2. Why is that, Amy? the sides of the triangle. When you plot a point, you start at the origin, you go to the right, whatever, and you go up, whatever. You went to the right, square root of 3 over 2, and up 1/2 to get here. These numbers just came from the sides of the triangle. That's all they are. Does that make sense? Once you see that? Okay, very good. All right, so now I'm going to take this triangle, and you are too, and I want you to reflect it down. So we are now in the 4th quadrant, so we're going to put a 4 in there, and we're going to label everything else. This was pi 6. This length is still square root of 3 over 2 because we're just on the back. Put in my little right angle. This is still 1/2, and the hypotenuse is still 1. So taking the information from my triangle and knowing what I know about coordinates in the 4th quadrant, I should be able to easily come up with this ordered pair. What would the x value be? Square root of 3 over 2. What would the y value be? Negative 1/2, because in the 4th quadrant, your y value is negative. On the triangle, it's still positive because it's a side length, but when you're talking coordinate plane, it's negative 1/2. Okay, does that make sense? This angle right here is pi 6. This angle is 11 pi 6. But the pi 6 part of this, that is your reference angle. Remember us talking about reference angles yesterday? The shortest way back to the x-axis is your reference angle. So that is pi 6. Okay, we all good so far? All right, so now I want you to take your green Roman numeral 2 triangle and put it down in the 2nd quadrant and line it up all nice and pretty. And put that little piece of tape right there. Then we're going to do the same thing we did, which is reflect it down, straighten it up, and then put another piece of tape on it. And when we put this back up into the 2nd quadrant, we are at the angle that is 5 pi 6, but the reference angle is pi 6. Okay. So make sure you put pi 6 on your angle right here. So in the 2nd quadrant, something you've known about the 2nd quadrant for years and years is that your x value is negative, your y value is positive. So to get the ordered pair from this, this would be a negative square root of 3 over 2 positive 1/2. Right? Then when I reflect this down, let's fill in this triangle. Angle is still pi 6. This length is still square root of 3 over 2. A right angle. This is 1/2. This is 1. And I'm in the 3rd quadrant. Okay. So now in the 3rd quadrant, we know that the x and y are both negative always. So that means that my x value is negative square root of 3 over 2. My y value is negative 1/2. So let's look at what we just filled in. We just filled in the ordered pairs for all of the angles that have a 6 in the denominator. And there's only 4 of them, and all 4 of them have a reference angle of pi 6. Remember, if you have an acute angle, like pi 6, its reference angle is pi 6. It is its own reference angle there. So all of those ordered pairs have the same values. The only thing that changes is the sign depending on what quadrant you're in. Okay, does that make sense to you? So I know you may not recognize this right now, but that's going to make things easier to keep up with and remember once you have to start actually knowing this stuff for real. Now let's talk about why we care. Like, why do I even care what that ordered pair is? Well, let's look at, we need to know the trig values, right? We need to know the sine, the cosine, the tangent of these. Well, the sine of pi 6, or of any angle, is opposite over hypotenuse. So if I put opposite over hypotenuse, that's 1/2 over 1, which is 1/2. That's that number right there. The cosine is adjacent over hypotenuse, so that would be square root of 3 over 2 over 1, which is just square root of 3 over 2. So since the hypotenuse is 1 on all of these, your sine and cosine values are just your x and y values. So the adjacent side is your x. This is always going to be cosine theta on a unit circle. And then your y value is sine theta every time. So if I ask you, what is the cosine of pi 6? It's the square root of 3 over 2. What is the sine of pi 6? It's 1/2. Okay? When we get down here to 7 pi 6, the cosine of 7 pi 6 is negative square root of 3 over 2. Okay? We good with that? Okay? And it'll get easier to actually know how to use the unit circle right now and find them, and then we'll get to the rest. Okay? We all good at this point? Any questions? All right, grab your pink Roman numeral 1 triangle, and you're going to set it down right on top of your green one, like so. And then we are going to put, once again, a little piece of tape right here. When you reflect it down, it's most likely going to need a little adjusting. And then everybody look up here real quick. When you tape it when it's down like this, you are taping it right to the green one, just like that. Okay, it just tapes right on top of the green one, and then you'll be able to flip it up and down just fine. Okay. All right, so 45 is half of 90, and we know that 90 is pi halves, so 45 has to be pi fourths, right? So let's put a pi fourths right here on this angle. Sorry if this looks a little blurry. I keep trying to fix it, and I don't know if I can't get it right because my eyes are bad or what, but I think you can at least make out what it's supposed to be here. All right, so if this is pi fourths, this is the ordered pair I'm looking for. My x value is the square root of 2 over 2, and my y value is the square root of 2 over 2. Right? They're the same. Because the two angles are the same, the sine value and the cosine value are the same, which makes pi fourths pretty easy. Right? Okay, so then I'm going to reflect this down. We're going to fill in this triangle, this pi fourths. Side lengths are square root of 2 over 2 and square root of 2 over 2. Put in my right angle, make that a 1, and this is the fourth quadrant. We good? So that means here, I know the two values are both square root of 2 over 2, but which one is negative? X or the y?
Y.
Y. Negative square root of 2 over 2. Right. Well, got that one pink one done. So grab your Roman numeral 2 pink one, put it on the second quadrant. Go ahead and tape it, reflect it, fix it, tape it. So this 45 is pi fourths. The actual angle where we are is 3 pi fourths, but our reference angle is pi fourths. Just like when we were in the fourth quadrant, it's 7 pi fourths. The reference angle is pi fourths. Okay. So my side lengths here are square root of 2 and square root of 2 over 2 and square root of 2 over 2. but I'm in the second quadrant, so that means that I have a negative square root of 2 over 2 for the x value and a positive square root of 2 over 2 for the y value. Right? Then I'm going to reflect it. We'll fill in our triangle. We got pi fourths, square root of 2 over 2, square root of 2 over 2, a right angle, 1, and we're in the third quadrant. Okay, and then go ahead and fill in your ordered pair. X and Y are both negative in the third quadrant, which means that if you get a third quadrant angle, you know your sine and cosine are both negative. Whatever the values are, the sine and cosine are both going to be negative if your angle's in the third quadrant. Okay. Everybody good with your pink angles, or your pink triangles, rather? So we did all of the angles that have a 4 in the denominator, all of our what I'll call pi fourths angles. You got pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths. Okay? There is no 2 pi fourths because 2 pi fourths is actually pi halves, right? So that's when I say count fractionally, here's how we can count fractionally if we talk about pi fourths. This is 1 pi fourth, right? This is 2 pi fourths, but that reduces to pi halves. This is 3 pi fourths. This is 4 pi fourths, which reduces to pi. Then we have 5 pi fourths. Then we have 6 pi fourths, which reduces to 3 pi halves. 7 pi fourths, and then 8 pi fourths, which reduces to 2 pi. You can just count around in fourths or thirds or sixths or whatever and get around your circle. Okay, we good? All right, take your Roman numeral 1 yellow triangle. And let's put it down right on top of the pink and green, just like this. Tape it, reflect it, fix it, tape it again. $60 is pi thirds. 30 is pi sixths, right? Very tiny little bit that we got to make sure we know about tomorrow. So for this 60 is, I'm going to put a pi thirds. And it helps when you're trying to remember all the stuff that you're going to have to remember. If you can kind of picture this circle in your head and you can picture where things are. There's times like I'm going to be standing at the door a lot, quizzing y'all as you come in. And I see people like, they may not even do anything with their hands, but I can see their eyes kind of go like this. And I know that they're thinking around the circle, or they might even do this. Like whatever works for you, try and visualize this circle. Because the ordered pair for this, let's look at this and talk about that a little bit more. My x value is going to be 1/2. My y value is the square root of 3 over 2. Those are the exact same values for pi sixths. It's just that x and y switch places, right? And we recognized that the other day when we were filling some stuff in, that the sine and cosine switch places from 30 and 60. So if you know these values, because very quickly you will know the values you have to know, you just got to put them in the right places. And if you can picture around the circle and you know that pi thirds is up here and down here, well, up here, you're going to have to go up farther than you go over. So the x value would have to be 1/2. This would be the y value. That's how you know, like, if it's more or less, which way did I go? And the visual aspect of it will help you. Different things help different people because your brains all work differently. But if you're at least a little bit visual, that does help. Okay, we good on that one? So we're going to reflect it down. Let's fill in our triangle. So this is pi thirds. This is 1/2. Square root of 3 over 2, 1, and I'm in the fourth quadrant. My x value, positive 1/2. Y value, negative square root of 3 over 2. Reference angle for 5 pi thirds is pi thirds. because you got pi thirds more to go to get to 6 pi thirds, which is 2 pi. Right? What's the reference angle for pi thirds? It's a super easy question that seems very confusing. It's pi thirds. The reference angle for pi thirds is pi thirds. If it's a first quadrant angle, it's its own reference angle, which might seem weird. I don't like to ask reference angle questions like that because they do seem tricky and confusing, but I think it might pop up in Delta Math. That's why I want to make sure that you understand that. Here, 5 pi thirds, the reference angle, pi thirds, see? Here, pi thirds, reference angle, pi thirds. It's for the same reason. It just seems strange that it's its own reference angle, but it is. All right, take your last triangle. Let's put it down in the second quadrant here. You are going to tape it, reflect it, fix it, tape it. I'll give you a second to do that. You know the drill at this point. $60 is pi thirds. Just a little side note, want to remind you that your retest and everything is due by next Tuesday. I'm not extending it this time. I extended a lot last time because I was out so much, but got to be done by Tuesday. All right, so we're here. We've got we know that in the second quadrant, your x value is negative, so this is negative 1/2, positive square root of 3 over 2. Then I'm going to reflect it down, and we'll fill all this stuff in. Pi third. I think you can fill in your triangle and fill in that order pair without me, because I'm quite sure you got the hang of this by now. Okay, so if you have talked, because I've already heard some people go, oh, I heard the unit circle was hard. Well, you probably heard that from people that never practiced it and never learned it, because it's really not that bad. Yeah, I know it seems overwhelming right now that you have to actually know all this stuff, but it's not, memorization is never a good idea. Learning it and understanding how it works is what you need, and I will get you there as long as you don't resist me. Okay, so let's look at what all we have to know and how much information that really is. Yes, you have to know all of these ordered pairs and what angles they go with, but not by tomorrow. But let's look at what that means. Let's see. We have the same numbers over and over again. So if I look at this, and we're going to ignore the negatives for a minute, because the negatives have to do with the quadrants. So we're just going to look at like the absolute value of the numbers. But 1 and a 0, so that's 2 numbers right there. I have a square root of 3 over 2. I have a 1/2. I have a square root of 2 over 2. That's the same number. These are the same numbers as this, and then I get 1, 0 again. Then they're all the same. It's just the signs and the placements that changes. That's a total of 5 values you have to know. Then you just have to get them in the right places, and I promise you, I will make sure you understand how to do that correctly and easily. Okay, we good? So it's not that bad. Okay, there's not like a bazillion random numbers you have to know. And trust me when I say knowing the angles is radians, way easier than knowing them as degrees, and I will show you a ton of patterns of those starting tomorrow. Today it would be a little bit too much because we still got some other things to talk about. Okay, we good right now? Okay, so let's go to the top, actually the bottom right of your paper. We're going to fill some things in the corners. So we talked about the fact that these are all ordered pairs that we have to know, and the ordered pairs are always cosine theta, sine theta when you are dealing with a unit circle. And right now we're only dealing with a unit circle, but we could have a circle that wasn't a radius of 1. Then we have to look at the angles, this information a little bit differently. I couldn't just take the x value. Okay. All right, let's go to the top left of the paper in this corner. So we know from SOHCAHTOA that sine theta is always opposite over hypotenuse. We've known that for a while. That's definitely not new business. So if I look at one of these triangles here, and I say, all right, well, that's opposite over hypotenuse. That is the y value. The opposite is the y value. The hypotenuse, what part of the circle is the hypotenuse? Well, it's 1, but what part of the circle is it? What's it called? The radius. So it's y over r, y over the radius. That works for any circle ever. You take a circle with a radius of 5, and you take a y value over the length of the radius, and you're going to get the sine value for that angle. But in this case, the radius is 1, so that means it's just y over 1, and that's why sine theta is just plain old y. Okay? Your y values on all these ordered pairs is just y. All right, so then let's go to the bottom left. Let's talk about cosine theta. We know from SOHCAHTOA that cosine is always adjacent over hypotenuse. Okay, so for one of these triangles, the adjacent is the x value, the hypotenuse is still the radius. So this is x over r, but for a unit circle, that's just 1. And that's why cosine theta is just plain old x. Okay. Does that make sense to you? I hope. All right, so let's talk about tangent, because we hadn't talked about tangent at all today. Let's go to the top right over here. All right, so we know from SOHCAHTOA that tangent theta equals opposite over adjacent, which means if you're on the coordinate plane, opposite over adjacent, that's going to be your y value over your x value every time. But we can look at tangent a little bit differently because we have a different value for y and x, right? We know that y is sine theta and x is cosine theta, so tangent is also just sine over cosine. Now let's look at tangent even a little bit more. I'm going to reflect down all of your triangles in the first quadrant here. There was supposed to be a faint line right there, but I don't think it copied very well. So your ID makes a great straight edge, but just go ahead and draw in that line because I don't think you can see it on your copies. You can barely see it on mine. So then now that you see a triangle there, even when your green triangle isn't there. Okay. So the next thing you're going to draw in is we're going to draw in a line tangent to the circle at this point, which means my line needs to be perpendicular to the x-axis. Just do the best you can to make it look perpendicular because I'm not going to give you the tools to make sure it's 100% right. And you will I'm going to draw right through some ordered pairs, and that's totally fine. Like I even drew through some of my numbers. That's fine. Just drawing that line. Then one more thing you're going to draw in from this point here, we're going to continue this radius so that it actually hits that line. So it looks like this. And I'm going to go right through my square root of 3, but you see that? So I just extended that to that line. This point right here on the x-axis, we're going to label B. And this one that's right next to my square root of 3, we're going to label A. All right. So now within all of this that we have two overlapping triangles. We have this one that's the same size as your green one, and then we have the one that starts here and goes to A and B. You see those overlapping triangles there? So they're overlapping and they're similar. So since they're similar, we can set up a proportion. You've been doing that for years, okay? So I'm going to set up a proportion. I'm going to put sine theta over cosine theta. So I put this side of the little triangle over this side of the little triangle. That means in my next fraction, I have to have this same corresponding side of the big triangle on top. So that's going to be the length of AB. And then underneath that would be this side. What is the length of this side of that big triangle? 1. Right? Does that make sense? So I put sine over cosine, AB over 1. So proportional, it's just a proportion from similar triangles. So what that tells me is this. Well, AB over 1 is just AB. Sine over cosine is also tangent. So the length of AB equals tangent theta. So where this is the cosine value, this is the sine value, this part, the length of AB, right here, that is, not that you can see I just drew on it, but that is tangent theta. That says tangent theta, you can see it. Now that doesn't really help us find side lengths, find the actual value of tangent, but what it does do is hopefully help you see that having a tangent line and a tangent value, even though they mean two different things, they are related. Okay, because when you first learn tangent lines and tangent and trig, they seem like they're two completely different things, but this is why a tangent is called a tangent, basically. All right. So let's talk about some values. Let me ask you again a couple of things about this. What is the cosine of 5 pi sixths? 5 pi sixths, what is the cosine? Is cosine x or y? Cosine is x, so my answer is no. The cosine of 5 pi over 6 is negative square root of 3 over 2, right? The sine of 5 pi sixths is 1/2, because the sine is the y value. The cosine is the x value, okay? So what is the cosine of 2 pi thirds? Negative 1/2, right? That's how you just get this right off the unit circle. The sine of 2 pi thirds is square root of 3 over 2. What is the cosine of 4 pi thirds? Negative 1/2. 4 pi thirds, the cosine is the x value, it's negative 1/2. Do you see how to use this to find that stuff? Okay, so right now you need to be able to use it to find it, and then we'll learn how to do the rest of that, but know how to read this off of this and what it means. So let's talk about tangent, because I can't just look at this and know what my tangent value is, so we'd have to find it. You don't have to write down what I'm about to write down, because we're going to do a lot of this tomorrow. I just want you to see how this works. Let's say that I want the tangent of pi thirds. Okay, so I'm going to find the tangent of pi thirds. So I know that tangent is sine over cosine. And I know what the sine and cosine of pi thirds is because they're right here, right? So if it's sine over cosine, the sine is the square root of 3 over 2. The cosine is 1/2. And then that just means that's the square root of 3 over 2 times 2 over 1. So that gives me the square root of 3. So the tangent of pi thirds is the square root of 3, something we could find right now if we needed to find. We'll find them all together tomorrow, and we'll talk about how we can just know them and not have to figure them out every time. But if I had to figure them out, I could. The tangent of pi fourths is easy, because if tangent is sine over cosine, I put square root of 2 over 2 over square root of 2 over 2. What does that give me? 1. They just cancel each other out, and it's a 1. All right, tell me, first of all, what is the secant the reciprocal of? Cosine. Cosine. So look at pi thirds. What is the secant of pi thirds? So the way you go through this is, if you know secant is the reciprocal of cosine, if I ask you for the secant of pi thirds, the cosine of pi thirds is 1/2. What's the reciprocal of that? 2. So the secant of pi thirds would be 2, because it's just the reciprocal of the cosine value. Does that make sense? We don't have to go do hypotenuse over adjacent. We can use the cosine values to figure that out. It's going to be way easier to do secant, cosecant, cotangent through the values of the first 3. So we've got to really know the values of the first 3. We're not going to really discuss the reciprocal values just yet. I mean, I wanted to show you how it works, but because we're going to make sure that we get the other ones like really, really down. Okay, and again, I will help you step through that, but you've got to stay with me and actually practice. Okay, we good? All right, so go ahead and fold this in half so you don't destroy it. Hang on to it. We're going to go over it some more tomorrow and the next day, and we got other things to go along with it. All right, you do have a short Delta Math assignment today. Make sure you read the directions. I've had some people say, well, I keep getting the right answer, but it's counting it wrong. It's because you didn't do everything it asked you to do. Read the question.